A man walked from his campsite, point A, for 12 kilometres on a bearing of 70 degrees to point B. He then walked for 10 kilometres on a bearing of 180 degrees to point D. 1. Complete the diagram. 2. Find distance B to C to 2 decimal places. 3. Find distance C to D to 2 decimal places. And 4. Find the bearing and distance D to A. Okay, firstly, he walked from point A on a bearing of 70 degrees. Now, when it's written 070 and it's called a bearing, it means that it's 70 degrees clockwise from the north position. So this is 70 degrees here. Now, he's walked a distance initially of 12 kilometres. So this is 12 kilometres. He then walked for 10 kilometres on a bearing of 180 degrees. Now he's now at B, so just imagine there's a new north here. 180 degrees, that's 180 degrees there. And he's travelled 10 kilometres, so BD is 10 kilometres. So BC is an unknown, so we'll call that X. And we call CD 10 minus X, because we know that BD is 10, and we know that BC is X. You should be familiar with the Z rule. When you've got two parallel lines, this angle is equal to that angle in the Z. It might have also been called angles of elevation and angles of depression. So we can go ahead and put 70 degrees into that position. Now we've got enough information to solve for X. So we know this is a right angle here, so this is the hypotenuse, which is 12, and the adjacent to the angle of 70 is X. So that's a COS problem. So cos theta is equal to adjacent on hypotenuse. Cos 70 is equal to X on 12. Bring that over to multiply. We've got 12 cos 70 equals X. And solving on the calculator, that gives X equals 4.10 kilometres. And that equals BC, which is the answer to question 2. Now we go ahead and work out part 3. So we want to work out what CD is. We know it's 10 minus X. So CD equals 10 minus X. And we can sub this value in now. So CD equals 10 minus 4.10. And that equals 5.90 kilometres. Okay, to find out the bearing and distance D to A, the true north has got to be drawn from the position D, and so the angle, the bearing angle you actually want is that. Now let's just go and put our values in that we've already worked out. So this is 5.90 and this here is 4.10. In order to find this bearing, we need to find what this angle is here. We've only got one known here, so what else can we find? Using the triangle above, we could find A, which is distance A to C, and then we could use A and the value of CD to find this angle. Okay, working with information in the top triangle, we'll work with the angle of 70 degrees, we'll work with the hypotenuse, which is opposite to the right angle, and we'll solve for A, which is the opposite value, so it's a sine problem. So sine theta equals opposite on hypotenuse. Sine 70 is equal to A on 12. Take that over to multiply. You've got 12 sine 70 equals A. And working it out on the calculator, you get A equals 11.28 kilometres. Let's call this angle here beta. Now we know the opposite is A, the opposite to that angle, and the adjacent is this value, 5.90. So it's a tan problem. So tan beta is equal to opposite on adjacent. Tan beta is equal to A on 5.90. Now we know that A is 11.28, so we can put that in straight away. 11.28 on 5.90. So beta equals the tan inverse of 11.28 on 5.90. Now that's got to be done as a whole calculation before tan inverse is performed. So putting that in the calculator, you will get to the nearest degree, beta equals 62 degrees. Now that's not the end, that's not the bearing yet. So remember, we want this large angle as our bearing. So what we do know is that the angle of a full circle is 360. So the bearing that we're looking for, this large angle, must be 360 minus beta. So the bearing equals 360 minus 62 equals 298 degrees. And finally, for the distance from D to A, we can use Pythagoras. We know the value of A now, and we know the value here. So AD squared is equal to A squared, which is 11.28 squared, plus CD squared, which is 5.90 squared, equal 162.05. And then finally, AD equals the square root of that, which equals 12.73 kilometres. D to A equals 12.73 kilometres on a bearing of 298 degrees.